right, good morning again, everybody. So we are still in module 7. So still dealing with iterative statements. In case you didn't notice the roadmap until the end of the semester, it's going to be relatively smooth. Okay, we're going to revisit this. We're going to, next module, start messing a little bit with method again. So it's nothing new really, but what we're going to cover regarding method is going to be new. And that's going to open the door to a topic that is actually a hot topic for COP2512, which is recursion. So I'm not going to tackle recursion like right now in the module M08. We're going to skip it. But once we are done with M8 and M9, which is going to be arrays, then if I have time at the end of the semester, I will sneak in something about recursion. Okay, it's not officially as a topic for this course, but the deal with recursion is the sooner you are exposed to it, the more chances you get to practice it, the better you get at it, like a lot of things in programming. So if we do have time this semester, yes, I would like very much for you to start doing a few basic exercise on recursion so that when you get to COP4515, then you're not, just discovering for the first time recursion. All right, but for now, back to module 7 and back to the slides on which we stopped last lecture. So we were looking at an example, again, yet the same example. We have one example of counter-controlled loop that we have been dragging through the entire module, and one example of sentinel control loop. So here, this is again, the program that asks the user to enter some values, and I'm going to sum them all. And when you enter 0, I quit. Okay. So here's the prelude for the program. And then we're going to start looking at different versions. And I'm going to put those back on the slide here to refresh your memory, because as we go through over a statement, we're going to come back to the same code, but make more and more versions of it, just so that you can compare and contrast and kind of see, like when it's appropriate to use one construct instead of the other. So the basic version that we have here, this is what we have been doing not most of the time. This is what we have been doing a few times at the beginning, where we would ask the user to enter something. So that's the code at the beginning right here, system.out.println a prompt of some sort, and then next thing to read a value. Then we would enter the loop. And the deal is that in that version, we read something from the user first, then we use a while loop, and we test the condition, which makes sense because the condition is based on the values the user enters, okay? So that's probably the first version of that code that I've used in this class because it's kind of the most natural that comes along. If the condition is true, then here we go, add that value to the sum, and then a little bit of a wonky, stylish thing here. I repeat again the code that I had here. So why do I do this? Because I wanted to read a value first, and I wanted to get in the loop, and now at the end of the loop, I need to read the value again. So I don't have really a choice until I introduce, something like the do while, for example. There are actually different alternatives, so let's go over them. The first alternative is that I'm not going to introduce a do while yet, but I'm going to set my value here to some initialization number that is not a valid number, and that is not actually like the sentinel value, okay, 0, for example. So minus 999 would have been better if I was accepting only positive here. But bottom line is that I set my variable value here, I initialize it so that it would pass the condition the first time. So I don't need to do this anymore. I jump here. The first time it's rigged, it's totally rigged. I'm going to have this condition true because of the initialization. I'm going to go here. So I moved the displaying of the prompt and the reading of the int to the top of my loop. And then once I have a value, well, again, the general case is 0 is nice because I can add 0 and it's not going to make a difference. But the general case is you don't want to process your sentinel value. So I have a little if here that says if the value is different than 0, then add it to the sum. Else, nothing to do. Reach the end of the loop, go back here, check if the value was 0, get out of the loop if it was. Okay? So that's an overtake on it. So refactoring, right? The meaning of the code didn't change. The way we wrote it changed a little bit. And then here's a third version based on what we have seen so far, which is with a do while loop. Do read something, check if that something is a sentinel. If it's not the sentinel, then use it. Else, nothing to do. While check if it was a sentinel. If it was not the sentinel, continue. If it was a sentinel, get out. Okay? So 3 different evolution. This one is wonky because of the code repeat. This one is wonky because this is a magic value. Okay? It has a specific magic meaning in that context, which is just I want to skip the loop. So you'd better comment that kind of stuff. Otherwise, 6 months later, you don't remember why 999 is so important. Okay? And this is actually probably the cleanest of all the version that we have seen so far. So bottom line, yeah, it's still a little subjective. I'll get you that. I'll give you that, right? But you can maybe start seeing now that all of those extra constructs that we bother with, they still serve a sort of goal, a utility. They have a utility. It's a little niche, okay? But they have a utility. They allow us to reformulate code sometimes a little bit more simpler, a little bit more easy to read, or even a little bit easier to read if you speak proper English. All right. So let's continue, no pun intended, but let's continue with some syntax. So we have like the 3 types of loops in Java, the for loop, the while loop, the do while loop, that's it. Okay, that's all we have. So 3 different syntaxes to do some looping in Java. And then we have 2 keywords that make sense in the context of loops, break and continue. Actually, what I just said is not entirely true. The continue keyword makes sense only when it's used inside the body of a loop, granted. But the break keyword, we encountered that already. Remember where? Where did we encounter the break keyword? Switch, yeah. So switch statement, the break keyword, what did it mean? A break inside a switch means get me out of that switch, okay? A break inside of a loop is going to be get me out of that loop. So it's a contextual keyword, right? It's one of the few actually that we encountered so far that is purely contextual. You have to look at what is the block of code in which the keyword occurs. And depending on what it is, well, it still means get out, right? But it's get out of a switch or get out of a loop. What if you have a loop inside a loop, inside a loop, inside a loop, and a break statement right here in the middle? It gets you out only of the surrounding loop. So then you would reiterate the loop around it and restart again that inner loop, okay? So you just go out of the immediate switch, go out of the immediate for loop or while loop or do while loop. And these work with any kind of loop syntax. So here's an example that's going to illustrate what's going on with the break statement. So sum initialized to 0, so we're going to add up some numbers. Here are the numbers start at 0, while number less than 10, so number is our loop counter. I increment number at the beginning of the loop, why not? I start at 0, then I'm going to go immediately to 1, and then I start adding 1 to sum, then I keep going, and then 2 to sum, and then 3 to sum, and I'm supposed to go until 9. When number equal 9, I still add 9 to sum. When number equal 10, I'm done, okay? That's what this condition tells me here. But this condition here, this is kind of like an additional reason to stop the loop. It says, if at this point in the loop, I just added number to sum, if I realize that sum is becoming bigger or equal to 30, then break. So I'm not in a switch statement, I'm in a loop, so break out of the loop, that means jump out to here, okay? So that's the deal of the break statement, the break keyword, sorry. Nothing really like fancy there. The one thing that's interesting is that now it allows you to have different kind of logics for terminating your loops. What we have been using, and that's what I finished last lecture on, I was trying to kind of, brush a picture of what made all those types of loop similar to one another, the for, the while, the do while. And I told you one thing, I told you all of these loops, they have continuation condition. While something, as long as the something is true, I keep looping. Do while something, again, while this is true, I keep looping. For, this is just a while loop in disguise, okay? So the meaning of the condition was, if the condition is true, keep looping. This is different. This is called an exit condition. So with a break keyword, because a break keyword gets you out, you can have like an if statement that say if sum greater or equal to 30 or whatever number you want, then get out. That's my exit condition. That's my continuation condition. So I have two different ways to look at how I'm going to get out of the loop. Okay? All right. So if I run this, number is 8. So at the end of the loop, number is going to be 8. So we are not going up to 9 because of that guy here. And the sum is 36. So the first time the sum gets over 30, then we are going to make sure that we pull the brakes and we get out of this loop. What about the over keyword, the continue keyword? So it's the same kind of ID. They are really related to one another. So whereas break gets you out of the loop, continue says, you know what? Let's restart the loop. Let's go back to the next iteration and ignore everything that was remaining in the body of the loop. Okay, that's the idea of continue. So let's take a look at an example. It makes more sense with an example. So same ID here. Okay, sum equals 0, number equals 0. We are going to iterate from number equals 0 to number equals 9, number plus plus at the beginning of the loop. And then I say if number equals 5 or number equals 6, continue. So I have a condition here. It's not an exit condition. It's not a continuation condition either. So break allows you to introduce exit condition, continue totally different, okay? But whenever that condition is true, so whenever I'm iterating on number and I stumble on number equals 5 or number equals 6, the only thing I want to execute is continue. And continue is going to cause me to jump not outside of the loop, but to the end of the loop. And I'm going to rewind, and I'm going to test my condition again, and maybe go for one more iteration. So continue means, okay, let's keep the rest of the loop. Let's get to the end. Let's rewind and see if we go again. So we skip this. That's all. If there was more code here, by the way, this is not in the else, okay? So if there was a block of code here, then we would have skipped everything that was remaining in the body of the loop when I hit the continue keyword, and that's it, okay? So the keywords are not difficult, okay? So in this case, if I run this, I'm going to get the sum is 34 because I didn't add up 5 and 6 to my sum, okay? The keywords are not difficult. You just need to do what we have been doing in module 1 to 3, which is pay attention, okay, when you trace code. So for example, if I give you this code here, take a look at it. This is not the worst that I can do. I try to save the worst for the CGQ, so you're going to see that. But it's not really that bad. But my point is, like, this one is good practice for the CGQ. It's one of the review exercises in the textbook, so some of them are really worth your time when you're studying the reading assignment. So pay attention to them. This I'll ask you pretty much to trace a code. So you don't have to make a trace table. Do it in your mind if you're okay, but go for it and tell me what's going to be displayed here. So it's not an infinite loop, but it's going to go on for a few iterations. So as soon as you have the first 3 digits, give me a little sign, a thumbs up, a wave or something, so that I know how many people have actually traced to that point. What's the first thing that's displayed? The first number that's displayed? Huh? 1. Okay. So let's start together with this. Okay. So the good thing with this example is that if you have any trouble reading the for syntax, or if you don't like it, uh, then that's going to get you over that roadblock. Okay. So this is a counter control loop, starts here, ends here. This is a counter control loop, starts here, ends here. The detail of the first counter control loop, I starts at 1. We keep going while I lesser than 4, so up to I equals 3, and increment I by 1 every iteration, basic stuff. The inner loop, it uses J as a loop counter, but same thing, J starts at 1. We're going to go up to and including J equals 3, J plus plus. Okay, so it counts 1 in the outer loop, 1, 2, 3 in the inner loop, 2 in the outer loop, 1, 2, 3 in the inner loop, 3, 1, 2, 3. Okay, that's the basic pattern. That's the basic pattern until the introduction of the break keyword or the continue keyword, because now we can mess around with that pattern. And that's indeed what we're going to do here. So here we multiply I by j. If it's greater than 2, break. So first problem, when I break, where do I break? I just mentioned that, right? If you are like in a loop, 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 and you have a break, it's just the loop that surrounds you directly. So the break here occurs in this block of code. This block of code here is the body of the inner loop. So that break is going to get me out of the inner loop, make me jump to the system.out println I. Okay, that's the first thing to understand. Second thing to understand, when does I++ occur? So I'm rewinding to the past lecture, right? I++ happens when I hit the end of this loop. So when I hit this curly brace, closing curly brace, I is incremented. What about J++? When does it happen? It happens when I reach the closing curly brace for that loop. Okay? So that's good practice, just with a little less obvious notation, maybe. Just making sure that you can track through them. Okay? And then the rest is what you have already learned to do at the beginning of the semester, which is focus, trace through code, simulate exactly what the execution does. So we're going to have to keep track of I and J. I equal 1. All right, so I initialize I equal 1. I is usable only in the body, in the scope of this loop, because it's declared inside the for syntax. Then I check the condition I lesser than 4. Well, yeah, it's 1. So I enter the body of the outer loop. J equal 1. It's a good thing I have two hands. So J is going to be here, I is going to be here. J is 1. J lesser than 4. Yep, it's 1. It's lesser than 4. True. I end up here. 1 times 1 equal 1. Is it greater than 2? False. So it's not greater than 2. I don't break. What else is there for me to do? No pun intended. Well, there's no else. So I'm done with that if statement. System.out println I times j, 1 times 1. Yeah, that gives us 1 on the screen. Okay? And that's it. There's nothing complicated. But if I give this kind of exercise, generally I don't get 100%. So I've been asking myself the question of why can't I get 100% of students doing perfect on that kind of exercise? I'm still dealing with it. Probably will deal with it until I retire. But that's actually also a question for you guys. Why, for example, can I not get 100% on that exercise? What am I missing? So that's part of studying, right? You need to figure out what's actually hindering you. And if what's hindering you is, I cannot believe we are still tracing code. I cannot bear it anymore. I'm going to jump out of the window. Granted, it's the first floor, but so if this is what actually prevents you from being good at this stuff, then you know what to do, right? Push through it because you're not even trying. Okay. So when I ask this kind of question, I can tell generally by body language who has given up before even to try solving the question. I can understand, okay, but that doesn't mean that this is a good idea. Don't give up. Make sure you stay on it, okay? Learn the skills. If you don't have the skills, everything else in programming is going to be like this, okay? All right, so we have our 1 here. Reach the end of the loop. What happens? J is incremented. J was the left hand, I think. So J goes to 2. I rewind to the beginning of the inner loop. Is 2 lesser than 4? True. 2 times 1, 2. Is it greater than 2? No. This system.out.println I times j, 1 times 2, 2, and so on and so forth. Okay. All right, so I'll let you do the trace table for that. If you, the less you want to do the trace table, I would say, the more you should do the trace table for that example. Okay, that's how it works. All right, what about this one? So again, we're going to do just the first, so what do we need actually to see a difference here? It's going to start the same way. You know what, I'm going to run through it with you because it starts the same way. It's really like very, very close. So it's going to start with 1 and 1, okay? So 1 for I, 1 for j here. We're going to display again 1 for the exact same reason as the first example. And we are not going to trigger the continue for the same reason we didn't trigger the break. So we're going to display 1. We're going to display 2, okay? And then we are going to, again, look back, display 1, display 2, 2 again, and 3. Do the trace table. Check out what's happening. It's not because you have break and continue that you have necessarily different outcome. The CGQ is going to be very good at showing you that, okay? So take a look, do the trace table, make sure that this exercise, this example here is working. Sentinel control design. Okay, so we are up to version 5 here. So we have a do while, but this time I just learned to use the break. So I'm going to do a do while with an infinite loop. We did that at the end of last session. And then I have an exit condition here that say, oh, by the way, if the user just enters the sentinel, I'm going to break out of the loop. So I don't need to have really a continuation condition here because I have an exit condition and I can do with only one of them. Okay, so yet another way to write the same thing. Now, version number 6, what if I use a break, but I use a while? Sure, why not? So instead of doing do while true, you know, the body of your loop, end of the while, it's exactly the same thing. I completely neutralized pretty much a continuation condition. It's worth nothing right now. I just use an exit condition. And just for sake of completude, version 7, what if I use a 4? Sure, why not? Here's a 4 that implements an infinite loop, okay? So this trio of version is a lot less interesting than the previous one. The previous one was interesting. Different construct, different syntactical construct led you to organize your code differently. This is exactly the same thing, except that we've switched, you know, the while into a do while into a for. Okay, but the structure is the same. So less interesting, but for the sake of completude, I wanted to show that to you as well. So what we have now is we have the technology to rebuild it stronger, faster, etc. We have the technology to make a mess again out of our code. So the whole point about while, do while, for, you know, all of this stuff was actually introduced under the header of structured programming, okay? And what does that mean, structured programming? Of course, the program is structured. Well, before to have all those statements, before to have all those statements, the only way we had to branch into the code, you know, at different locations of the code, like to rewind, you know, a loop, or to do a if I go here, else I go execute that. The only way we had to do that was a statement that became, you know, kind of known as a nefarious statement, go to. So the go to statement allowed us to write what we affectionately call spaghetti code, meaning that when you try to follow and understand code that has been written with a lot of go-to statement, you read some code, you say, for example, if this condition is true, go to line number 473. So that's here. Then you follow here, you read a little, go to here. Then you follow here. It's like a program, it's an adventure program, right? Like you follow the chapter, you decide, you know, if you go right or left every time. So it's really intractable. It doesn't scale up. That's why we switch to structured programming with the while, do while, etc. Those statements. Well, what we have here with break and continue, we have exceptions to that good rule, actually, structured programming. So we have exception, and that allows us to implement something that kind of looks like a universal loop. This is an infinite loop. So infinite loop means that it's not supposed to stop ever. Well, we are going to make sure it stops, but we can make sure it stops by using a break statement, okay? And if we put that break statement inside a if conditional, then that means that we have an exit condition here that's going to trigger the end of the loop. And then I can put that if with the break statement, I can put it at the beginning. If I put it early in the loop, it's like a while. If I put it right here, it's like having a while. If I put it after a little bit of work, it's still an early test loop. If I put it last, this is like a do while. If I put it before the end with a little bit of work left, this is a late test loop. Or I can even shove it in the middle of the code, in which case I have a, well, let's call it like that, why not, a middle test loop, okay? Or I can do all three. So I can do all three, or I can even shove more exit conditions here. Okay, so what are the benefits? Niche, extremely niche type of benefits, okay? Meaning that there will be maybe one time in your life, 2 times, something like that, depending what kind of programming you do. If you are programming inside the Linux kernel, that kind of stuff happens a lot, okay? But then again, Linux programmer, you see different kind of context, different goals, okay? So my point is, for an application developer, you probably will never have to deal with something like that, okay? So stick whenever you can to the structured programming, the basic while, the basic do while, the basic for. And then if writing your code becomes really awkward as you are following structured programming, then you need to know that you can make some exception. You can use things like that. As a matter of fact, in C, when you learn the C language, you are going, well, you probably won't be taught that there is a go-to statement, but there is a go-to statement in C. And it's used. It's used in the middle of the Linux kernel. So why would some of the best C programmers use a statement that is considered very nefarious, like giving you bad code that's hard to read? Because in that one error recovery code that is somewhere in the middle, I don't remember, of a driver in the Linux kernel, having a series of go-to statements allows you to implement in a very readable way a process whereby you try to do something. If it succeeds, you try to do something else. You go step by step. If it succeeds, you try to do something else. But if at any point you fail, you branch actually to some code that's going to undo all of the steps that you did until now. And it's actually easier to write with a go-to statement, a bunch of go-to statements, than with a structured programming approach, okay? So again, 99.999% of the time, structured programming, yeah, definitely. But I want you to be aware of why we have those, those exceptions that are still available in the language, even though people keep telling you this, you should not do that. So if I should not do that, why is it in Java? Okay, why is it in C? So on and so forth. All right. So let's talk about 2 bugs. The first one is a joke. What's wrong with this? Yeah? Yeah, okay. So I said it's a joke because I already mentioned that one, right? So if you remember, or if you become paranoid about every time I say a bug is a joke, you're not going to focus on the semicolon, etc. Good. Okay, that's good. That's going to prevent you from making mistakes. So yes, that semicolon here, well, that's an empty statement. So technically, after the parentheses, I don't have an opening curly brace. I have an empty statement. So what is the rule? If I don't use the curly brace right after the closing parentheses, that means the body of the loop is only that one statement. It's true for loops. It's true for conditional. So this is the body of my loop, right? And what is this? Well, that's just a block of code, okay? Since literally the second day of class, you've seen that. You've seen me open and close a curly brace like out of nowhere and telling you, well, this is kind of stupid, right? But just wait a little bit. Well, that's where it becomes relevant. And I should really put air quotes again around relevant. Same thing here. That can happen with a for, that can happen with a while, especially if you use that indentation for the curly braces. And then here, well, that one is okay. That one is actually necessary. So, okay, quick reminder, okay, we talked about that already. This is just the termination of the do while statement. So there's a little bit of a wonky exception here, but nothing too bad. This one is a lot more interesting. So when we started module 7, I introduced a for loop, and I told you pretty much a for loop is a while loop in disguise. Okay, it has the same logic. The condition that you test is a continuation condition, but that's true for all loops. And in addition to that, the continuation condition is tested early in the loop. So when you write a while, the first thing you do is test if you should iterate even once. If you write a for, again, that's the same thing you do. Okay, do while is the opposite. You do stuff and then you wonder if you should continue. So let's take a look at a very simple counter control loop here, always sum and a counter. So I'm going to count 0, 1, 2, 3, 4 with the variable I increment by 1 every time. And I'm going to say if I modulo 3 equals 0, so if I is a multiple of 3, continue, which is going to cause me to jump to the end of the loop, which is going to cause me to trigger that I++, and then I'm going to rewind to the beginning of the loop and test again I lesser than 5. There's no else to that if, but the last statement in the body of the loop, the one that I skip if I trigger the continue, is add the value I to sum. So I add the value I to sum, except if I is a multiple of 3. Then I skip it. Okay, and then I display the sum on the screen. What's going to be the sum here? All right, awesome. All right, so I told you the for loop and the while loop, they function the same way. So let's do what I showed you in the early slides of module 7. Let's rewrite that junk with a while loop. Okay, that should work. So while I lesser than 5, check, in the same condition, I is initialized to 0 before the loop, check. I++ at the end of the loop, perfect, same thing. The if is the sum is the same, continue is used exactly the same way. That should give me exactly the same result. So it doesn't. What do you think happens with this one? Say that again? It continues. When does it stop? Huh? No. So that's a little weird. This one is an infinite loop. Okay? So the question is not the fact that it's an infinite loop. Yeah, sure, why not? Okay, I can accept that. You know, if everybody agrees on that, then it's my job to figure out why, right? But that's the interesting part, is that we didn't change anything in the code. So why is it that in that case, on the right-hand side, we keep spinning the loop and we never end? It's a side effect of the interaction of the continue keyword with the way that the for loop and the while loop work. So until I introduced the continue keyword, what I told you before, that was, you know, the while loop and the for loop, they're pretty much the same. You can use them interchangeably in 99.9999 and over 9 again % of the time. Yeah, I was not really lying, but now that we introduce the continue keyword, here's that 0.00001% of the time where there is an exception. So what's going on here exactly? Well, let's start with the while here. If I modulo 3 equals 0, so when I becomes 3, for example, this is going to be true. So I want to continue, right? I want to skip adding I to sum. But continue doesn't mean skip the next statement or the next two statements. It means skip everything up to the end of the loop. So the continue bounces me here, and then I rewind and I test I lesser than 5. Okay? So if I call 3, this is true, continue. Go here. 3 lesser than 5, true. 3 modulo 3 equals 0, true, continue here. So actually, the fact that this loop is infinite is not weird at all. Let me rephrase that. Why is this one finishing? So the difference between the two is that The keyword continue tells you skip to the end of the loop, okay? And in the case of the while, yep, that's working. In the case of the for, I told you that whatever is written here gets executed at the end of every iteration when you reach the end of the loop. But that's when we need to hire a lawyer. What do you mean by end of the loop? Does that mean that when I reach here, I'm going to trigger that, but if I had to continue, I'm going to skip to the end of the loop? Or do I just skip to the end of the loop and still do my I++? What does that mean, the end of the loop? So because this program ends, actually, because it loops a few times, goes up to 7 and then stops, we can infer from that when I do continue here, I go to the end of the loop, and then anytime I reach the end of the loop, the for syntax increment I by 1. So in the left side, I is incremented at every iteration. In the right side, it's not. Therefore, we never increment I, we never change I. There's no chance we are going to get I above 5, above or equal to 5. Okay, that's it for module 7. So right now, we've had like a module 7, module 8 is going to be a little like that. We have like short and sweet module. If you don't feel that they are short and sweet, okay, if they cause you problem, that's just like a red flag. Come to office hour, let's work together, let's figure out what's holding you back, okay? But at this point in the course, most of you should feel some relief, even if it's the first time you're programming, because we are reviewing things, we're adding syntax on top of what we already know, and syntax is easier to learn than actually, writing code from scratch. All right. So self-check time. If it's not getting easier for you, come and talk to me. Okay. A few practice exercises to finish this. So this is pretty much the only reason. Well, one of the two reasons for which we learn, number system still, because that gives us good excuse for good little practice exercise. So I'm going to ask you to convert decimal to X. Put your solution there. Here's the solution. So the solution is in the slide so that you can compare with whatever you are trying to do. Guess the number game. I didn't even write a description. It's just ask the user a number, make up a random number that's going to be the one that has to be guessed and tell them, well, it's too big, it's too small, etc. We've done stuff like that. Palindromes, this one is new. So if you don't want to redo exercise that we have pretty much already done, skip directly to the palindrome, okay? A palindrome, it's a very common, classic, exercise for an introduction to programming. A palindrome is a word that you can read forward and backwards the same way, like radar, R-A-D-A-R, R-A-D-A-R, okay? So what we are doing here is we are writing a piece of code that's going to read a string from the user. And that string can have space character in it and stuff like that. And then it's going to double check that the first character is the same as the last character. And then the second to first character is the same as the second to last. And then the third to first, the third to last. It's going to check that the word is composed of the same character going this way and that way, so that we could read it the same way, whether we read it in the correct order or in the reverse order, okay? So it's going to be a loop. It's going to be a loop with two counters, okay? We need to keep track of the position here, and then at every iteration, we move like that through the string. And how do you get a character inside the string? Char at, okay? That gives you like the character located at a specific index. So try it out. So this one is a little bit longer. And then last but not least, the prime number. So I would say this one is less interesting than palindromes, because palindrome has this double, index counter in the loop. So that's actually a very good practice. But anyway, we want to display the first 50 prime numbers. So you know how you do that? You go through the numbers, 1, 2, 3, 4, 5, you keep going, okay? And then for each of those numbers, you check if any of the numbers before that were actually a divisor, okay? So let's say I'm iterating, I'm at 5. When I want to decide if I display 5 or not, I check, okay, can 5 be divided by 2? I skip 1 because 1 is a divisor for everything. So that one doesn't interest me. I start with 2. Can 5 be divided by 2? No. Can 5 be divided by 3? No, not exactly, not integer division, right? By 4? No. And I don't test 5 because the number always divides itself. So there we go. I have a prime. I display it. Then I go to 6, and I test again. Can it be divided by 2? Yeah. Oh, okay, well, that's not a prime. So I'll go to 7, and so on and so forth. Okay? So nested loops, just practice. As you do those exercises, try the different construct. Try the while, the do while, the for. In some case, it's not going to make a bloody difference. In some other case, it's going to make your code a little easier to read and write if you use a specific construct. And that's it. That's it for module 7. So again, we have like time left, so we're going to get started on module 8. Just give me once again here to pop it up. All right. So here comes module 8. So what we have left in the class at this point, we have module 8 that should take us between 2 and maximum 3 sessions. So it's kind of a little wonky because we start half a session here. So maybe 2 more sessions, count on that, okay? So all the IEs and stuff like that are going to be scheduled or are already scheduled actually based on that estimate, okay? So I'll revise if we go faster or slower. Module 8 is going to be on methods. And then module 9, which is going to be, so it's the last full module that we cover generally, it's on arrays. But there are 2 modules on arrays in the textbook. One that talks about arrays of data that are one-dimensional, think vectors, and one that talks about arrays of data that are multi-dimensional, think matrices, okay? So module 9 is vector, module 10 is matrices. So generally what we have time to finish up with is we cover module 9 in detail, and then module 10 is kind of the last module we cover, so I try not to emphasize it too much during the final exam, but we just look at how whatever we learn to do with arrays can be generalized, to arrays with many, many different dimensions, okay? So this is the last stretch for this class, okay? So push, you're almost there, you're almost done. Don't give up now. M08 method, reading assignment, as usual, it's not optional. There's a lot of red. So we have been using methods since probably module 1, they were introduced. Maybe not the first lecture, but like around the second to third lecture, I showed you how to write a method. And then what I've been doing is I've been like repeating, hey, this is a parameter, hey, we return value, this is a return keyword, hey, let's go play a little bit on coding that, okay? There is actually a lot that I didn't go into detail concerning methods. So this is the time where we're going to do this. And it shows here. It shows because in the learning objective of the chapter in the textbook, everything that's red is pretty much relatively new. We've done it, but we have not put a name on it. We have not explained why or even said how that was called, etc. So we're going to review all of that in the lecture. There's nothing really that's purely green. Some of the stuff could be red and green. I don't know how to do a zebra red and green color for my font, so that's why it's red. And then there are a few things that I leave for the reading assignment as usual. So it's new, it's old and it's new at the same time. It's going to be weird. So you're going to see when we start going through the slides. It's not a full house module. We don't have an IE for that module. The last IE that we're going to be will be IE 09, I think. Yeah. So we have like 2 IEs left. The TAs already started grading the one that was due Friday. You should get your feedback within a week, okay? That's the deal we have with the TAs. Then we're going to have 2 more IEs and we are done. So this is really the last stretch. Yes, this is the last stretch for the class, right? The IEs, starting with like the one that you just completed Friday, and maybe even the one before that. There's no scaffolding anymore, right? You saw that. At the beginning, I told you, hey, here's what I want you to code. These are like good times. Then I told you, okay, I'm not going to tell you what to code, but I'm going to tell you do this, then do that, then code this. And, it was good times too. It's over. So for the last 2 IEs, at least, you have been experiencing exactly what you are going to experience as the final exam. Okay? Here's a requirement. Do it. I don't care how you do it. Well, I do care when I grade, but what I mean is like you figure out how to do it yourself. Okay? So we have been training for that. We have 2 more in the way before the final, but that's it. That's like sometimes I get a question, how do I prepare for the IE? You prepare for the IE using the practice exercise and the coding bat exercise. The IE prepares you for the final. The practice quiz prepares you to the graded quiz. The graded quiz makes sure that you understand the concept. So in a way, you should even do that before you start doing practice exercise. Yeah. No, like multiple choice or here's a stack of paper, write code on paper. I don't do that. Okay. We use what we have been using all semester long, which is open book. It's really the final is an IE pretty much. Okay. It's just like a little less flexible. I cannot reschedule those. I cannot make exception as easily for those. But that's exactly an IE in terms of format. So we have been ramping up to that. Personal favor request from me to you this time. We have a survey here. It's completely, let's start with the interesting one. It's completely optional. So you really don't have to do it if you don't want to, okay? It's anonymous. And it's quick. It should take maybe, I don't know, like 4 minutes, something like that. Why am I bothering you with that? That is not part of the course evaluation. That is nothing. That is just me trying to understand what part of the CGQ was useful, what part was not useful, and whatever you guys would like to see improved. So what I ask you is I ask you 3 questions, and each question has a rating, and then it has a box, an essay text box, for you to type whatever you want to help me understand the rating. So the rating is the first level of feedback, okay? What about the general idea of a 2-step quiz? Forget about the software. Forget about the question that I ask you. What about the general idea? Is it something that you find useful for yourself or not? Rating, and then help me understand why or why not, okay? It's equally important that you explain why it helps you and why it doesn't help you, right? This is a thing that I keep repeating every time we do course evaluation to students. It's really important that you say both the positive and the negative so that we can take action on that. Otherwise, what happens is that if nobody mentions something that doesn't work, we keep doing the wrong thing. If nobody mentions something that works, we generally end up changing it because we say, well, nobody said anything about that. So, they are like lukewarm, neutral about it. I'm going to replace it by something better. And sometimes, yes, we replace it by something better. Sometimes we replace something good by something worse. So that's why the positive and negative feedback is useful. So the first question will be, what about the general idea? Second question will be, what about the question that we use this semester? Were they hard enough? Were they too hard? That kind of stuff. This is where it goes. So you may tell me, yeah, I like the principle, but I hate the question that you asked us. That's good. That's why we separate the feedback in different levels. And then the last level, which should be maybe going first, I don't know, is what about the software? This is an interface that looks like I'm back in the year 2005. This is horrible. Who designed this thing? Sorry, I'm a really bad web designer. Anyway, bottom line is, if it was buggy, if it was slow, irresponsive, stuff like that, this is where it goes. But it helps us, rather than ask you, how do you feel about the stuff we did? And then, generate like feedback that is unorganized. We try to organize the feedback in those 3 tiers so we can really pick apart. Like, for example, if somebody is really upset about the software, yeah, we need to change something here, okay? But that doesn't mean that the general idea is not worth pursuing or something like that. So again, totally optional. You don't have to, but please, if some of you can take that survey, I would really, really appreciate it. We have PEs for this module as usual, and that's about it. So it's a little bit of a lighter module, but not for the content. So I told you it's old and new at the same time, right? That's kind of contradictory, yeah, a little bit. So let's talk about the old stuff. When you read this textbook chapter, it's going to assume that you've never seen method before. We've seen method before. We use them. We program with them in coding that. So things like, for example, why do we even bother with method? Well, I'm just going to be going real quick over those things, okay? And you interrupt me if I go too fast, but those things are like easy. We go over methods. We introduce method in a programming language. Different reason, but the most obvious reason is we don't want to write code like this. What is this? Find the sum of integers from 1 to 10. So 1 plus 2 plus 3 plus 4 plus 5 up to 10. Then do the same thing from 11 to 20. So 11 plus 12 plus 13 plus 14, 15, etc. And do the same again from 21 to 30. So it doesn't have to be that I do the same thing like this, 3 times in a row. It's possible that I do it in the main method, then I need to do it again in one of my methods somewhere, deep in my code. And then 6 months later, the intern decide that he or she needs again to do something similar and implement this in their methods. What is the problem? Well, with that code, actually, the problem is probably minor, except if your micromanager of a boss decide that we're not going to display sum from 11 to 20 is. We're going to display sum of the numbers between 11 to 20 inclusive is, something like that. And then what you do is you look at your code. This is my code. This is in the main. I change a message, compile, test it, it runs. And then 2 days later, I get a memo that says, by the way, I asked you to change the label that you display on the screen. I'm like, I did? Well, I did, but the people who decided to cut and paste my code elsewhere, they never got that memo. So now I have to track down everywhere. It says sum from, to blah, blah, blah. So we have regular expression. We can do that kind of stuff. So I'm going to search through my entire code, etc. What if it was the number here? Instead of lesser equal, I needed to use lesser strict. Well, it's a little bit more complicated to search, okay? Because what am I going to search? A for loop? I've got 47,000 of them in my code base. I'm going to look for a for loop that declares a variable int I. Cool, I only have like 300 of those. And then so on and so forth. So my point is, that's why I'm starting today, and I'm going to keep doing that for like the whole COP2513. So spoiler alert, I'm going to keep telling you code redundancy is actually pretty nasty. It's pretty evil, right? It makes your code base very brittle. The more you cut and paste, the more you duplicate code that has the same purpose, and you spread it all over your code base, the less likely you are that you can fix a bug in one version and remember all of the version that should be updated at that point. So at the very basic level, a method is just a named block of code. And that's exactly how I introduced them to you in module 1. I told you for now, a method is like a way to cut and paste some code, give it a name, and when I use that name, I execute that code. And that's what we have been doing at the beginning. So here, I encapsulate my code inside a method named sum. I say the method returns an int, and I parameterize my code. This is a second aspect of it. It's not just about, this code has a name now, and I call it, and it executes, and I come back. No, it's also when I call it, I can tell it, this is where I want you to start adding numbers. This is where I want you to stop adding numbers. So now my code is a lot simpler, clearer. And if there is anything that needs to be updated, modified, fixed, corrected, whatever in the code, the logic of the code that do that sum, it's here. And most likely there is only one programmer in charge of that code here. And we can track who it is if we're using GitHub or like Git, even like, any code versioning software. So that's a lot better for scaling up. Doesn't really matter too much in COP 2515. 2513, most of what we learn to do is about scaling up software development. That's what object-oriented programming is for, to start getting more and more programmers inside the room together, writing larger and larger pieces of code. So method anatomy, we're going to go fast over that. Methods are inspired by mathematical function. And the first kind of method that we learned to use, actually, the very first one was system.add_println, which is not quite a mathematical function, okay, it doesn't return a value. But then after that, with codingbat, all of the methods that we implemented in codingbat were of the type that returns one value. And in Java, you can return only one value. And that value will have to be of the data type that is specified here right before the name of the method when you declare it. All of that we've seen already. Why do I say in Java you return only one value? How many of you already did Python? Okay, how many value can a function return in Python? Just to sign. No? Okay, so it can return one value like Java, okay, like C, like all those old languages, but it can also return multiple values, okay? So that's not something that is written in stone for all programming language. That's another one of those things that when you learn a new programming language, you're going to ask questions such as, okay, how does the return value from a method work in your language? Can I just return one? Can I return multiple of them separated by commas? In Java, no such foolishness. But in Python, yeah, that can be done, and that's actually pretty handy, actually. It's pretty handy, except if you write code for me in a project, I hire you to write code for me in a project, and you write a method that returns 15 values. That's actually, I'm not making that up. That happened with a student I'm working with. And then I'm asking myself, why didn't you encapsulate those 15 value as an object? They have to have a meaning, right? So it's not all good, but yeah, go ahead. Yes. So we haven't covered arrays, but you can return arrays, you can return objects, you can return reference data types. So you can return one of each primitive data type. And then if you return an object, well, if that object contains, for example, an array of values, well, you return one object, but it contains an array of value. If you return a string, you could say that you return a bunch of characters, right? So yeah, when we return reference data type, it becomes a little bit more interesting. All right, so let's just talk about like nomenclature, okay? We should be able to go over the next 5 slides relatively fast and easily. This is called the method definition or declaration. I don't make a difference in Java when I use the word definition or declaration of a variable, definition, declaration of a method. When you do C programming, there is a subtle little difference between declaring a function and defining a function, okay? So different language, again, different level of pickiness in the terminology. These are method calls, okay? So we've seen that syntax, we've used them. There should be no problem, okay? I think somebody asked me early in the semester, so I already answered that, but I mean, I would assume many people forgot, so I'm going to repeat it real quick. Somebody asked me if the order in which we declare or define our method matters. No. So I put here my method f after the main. I can put it before the main. I can shuffle all of the methods that are declared inside my class. Okay, it does not matter. Okay, what matters is inside each of the methods, the order of the statement. Yeah, it does matter. Okay, if you call this first and then you do println result, yeah, it matters. Okay, so the order of statement matters inside methods. But the order in which you declare your method in your class can be completely free. No problem there. More vocabulary. So the keyword public and static. This is called a visibility modifier. Visibility modifier, we're going to explore them in 2513, is pretty much, can other programmers that are working on the same project than me, can they actually use that method that I'm writing? Or am I somehow locking it down so that it can be used only in the context of my little class, okay? That's what a visibility modifier is for. We have been using public as a keyword. There are other keywords, public, protected, private, okay? We're going to study them later on, next course, but public is the one that's like super relaxed. It's like, yes, I'm writing code, and if you and I are working on the same project, you sure can use any of my methods. That's what publics mean, okay? Public, not publics. Static. So static modifier, I don't want to really dig into that one right now. So we're just going to say that this is pretty much all of our method are static method in this class. And then we change that starting COP2513. The return data type, so any of the primitive data type, or the keyword void, or the name of a reference data type. So yeah, any reference data type can be declared as being the return data type of a method. You just have to return an object of that class, pretty much. The method name, so always the same stuff, start with a lowercase, camel case notation, and then the list separated by comma of parameter and declaration of the parameters as kind of like if you were declaring variable, int x, comma, int y, comma, double z, and so on and so forth, okay? So you can have as many parameters as you want. Is that true actually? Okay, I would have to double check if there is a limit. Theoretically, you can have as many parameters as you want. There might be a limit on the size of the stack or something like that. You may run out of memory pretty much at some point. More jargon. When you talk about a method, sometimes we are going to have methods, separate methods that have the same name, okay? We encountered that already. They have the same name, but one of them is going to take one parameter of type int, the other takes one parameter of type string, okay? But they have the same name. So what we do is we refer to the name of the method plus the list of all the parameters, and the data type. We refer to that as the method signature. So that means that when I have two methods that have the same name, their signature should be different. So the name is going to be the same, but then maybe they have different number of parameters or different types of parameter. One takes a double, one takes a string, okay? So whereas the name of the method doesn't have to be unique always inside the class, the signature, the combination of the name and the parameters list and data types has to be unique. This whole thing here is called the method header. So that's just defined as in opposition to the method body, which is actually the block with the curly brace, what code I execute when you call the method. Again, in Java, we always stick the method header, or almost always stick the method header with the method body. So I declare a method here and define it. In C programming, you're going to see that the header can end up being separate, like in a totally different file called a header file, right? And then you will have the header again and the definition of the method in an implementation file. So those two components, yeah, let's introduce the vocabulary right now because you will end up making a difference and distinguishing the two. So the previous example had only one parameter. Here's an example with multiple parameters. And just because I'm going to use that example to introduce, I think this is the last bit of terminology we need for method, I'm going to introduce the notion of parameter and the notion of, this is repeat, arguments. So until now, I tried to use the proper terminology, but sometimes I just said parameters. Okay, I call the method max with parameter 2342 because I didn't want yet to make a big fuss out of it. So now that we are reading the textbook chapter that tells you everything there is to know about methods in Java, here's one more thing that you need to add to your list. Okay, when you call a method, the expression here and the expression here, they are called argument. You give arguments to a method. Actually, there's plenty of synonyms, okay? Check out the reading assignment. They're going to give you 2 or 3 synonyms for what terminology to use here. In this class and the next, we're just going to use argument, okay? An argument is what you give to a method when you call it, the value that you give to the method. These are going to be called parameters. Again, there are different names for them, but I like the argument and parameters because 2 different words for 2 different things, okay? Otherwise, some people call those the actual parameters, and then they call those the formal parameter, and a lot of people end up forgetting which one is actual, which one is formal, right? Well, the actual is the one that you actually give to the method when you call it, but you know what? So argument, parameters. Parameters are what's on the receiving end. And that terminology is relatively common across programming language, okay? So now that you are going to start paying attention to whether I'm saying argument or parameter when I narrate some code, that should hold for any other programming language that you study, that I can think of right now, I should say really. The single return value, so again, some language can return multiple values. So those language, generally, when they use the keyword return, they would say, here's an expression, evaluate that expression, that's the first value I want to return, comma, another expression, comma, another expression. They evaluate all those expressions, and they return all of those values in one shot, okay, with one return statement. In Java, it's just a basic return and one expression followed by a semicolon, evaluate that expression, get the value, return it to whoever called your method. That's it. And again, in Java, we need to make sure that this is going to be the same data type than that. Okay, you promise that your method is going to return, for example, an int. You better make sure that every time you use a return keyword, the expression that you evaluate is yielding an int value. What happens if you say you're going to return something and you never return it? Like, for example, return statement here, boom, commented out, missing return statement. That's one of the compiler error message that I like, because that actually is clear, right? Missing return statement, no problem. I can understand what you mean, even if this is the first time I bump into that error. Some of you have been getting that in coding bat, haven't you? So I don't remember who, because I'm not that physiognomist, but I know that at least, I would say, at least 3 students that talked to me about that problem. You were working coding bat, you wrote some code, and you know what? Your code was actually good, it was correct. But yet coding bat would not accept it, or more specifically Java, the Java compiler would not accept it and tell you that there are missing return statements. Even though you had 5 return statements in your code. So we're going to talk a little bit about that, okay? Before we jump into that particular bug that is a very common bug to have at the beginning, what if I don't want to return anything? The void keyword. So if you looked at the definition of system.out.println, it's a void method. It's a method that doesn't return anything. So in that kind of code, generally you don't find a return statement. You just reach the end of the method. And when you reach the end of the method, well, you return to whoever called you. You don't have any value to return. You don't have any expression to evaluate. That's all good. But does that mean that in a void method, I cannot use the return statement? No. You are allowed to use the return keyword, the return statement in a void method. But what am I going to return? I just said the method doesn't return anything. Well, you don't have to return anything. You can return out of a method without carrying a value that you deliver to whoever calls the method. That's okay. So that happens when you write, for example, return in your method, immediately followed by a semicolon, okay? If I do return and an expression, then the compiler is going to check that the data type of that expression matches the data type that you promise as a return value here. And since I put void here, nothing is going to match. But if I do semicolon, that means just return, get out of the method. We are done. It's kind of like an exit statement, right? Get out of the method. So if that condition is true, get out and do not return anything, no value. So void, that's okay. Okay. So you can use the return keyword as an emergency exit. You're like in the middle of your method and suddenly you detect, oh my God, I'm about to divide by 0. Return. Screw that. I'm not going to try to work anymore on this code. Okay. My parameters were bad. Whatever happened, I get out of the method, return to whoever called me. Okay. So that's allowed. That's perfectly allowed. And now we get to the coding bat one. We get to the one that's fun. So I put 5 return statements in my code. The 5 return statements are followed by an expression that has exactly the data type that I promised I would be returning from this method. Yet the compiler tells me missing return statement. What's happening? So let's start with something that works and let's break it progressively. Public static int max. So max is going to return an int. It takes 2 parameters, a and b, of data type int. I have a local variable here in my method called the biggest. I set the biggest to a by default. I assume a is the biggest. And then I check, oh, by the way, if a is lesser than b, oops, so biggest is b instead. And then I return biggest. That's what I told you to do with all the coding bat exercise. When I first pushed you onto codingbat.com, I told you every time you're going to write a method, it will have to return a value. What I encourage you to do is at the beginning of the method, you declare a variable named result, or in this case, biggest is okay, of the same data type that you're supposed to return, okay? And then on the last line of your method, you do return that variable. So the idea is that I'm setting up here to compute the value of biggest in this code. And I start with an assumption, a default initialization, whatever. Then I have code here that's going to change that value based on what parameters you actually gave me. By the time I reach the return statement, that variable needs to contain whatever I want to return. So this is a one-way exit method. That means it starts here executing, and then there is only one return statement in the whole method that is right before the end of the method. So when you reach the end of the method, you return, okay? If you have returned right before the end of the method, there's still only one way to get out of the method is to execute all the code. Yeah?
Can you put a shorter byte inside that method? Can you pass that through it, or are you not allowed to do that? Smaller.
Can you put a what inside the method?
Sorry.
Sorry.
Shorter byte because it says end at the top. Can you put like a smaller data type through it?
Yeah, you can, but you have to be careful, right? So if you do that, like if you say, for example, max returns a byte or returns a short, okay, what I would say is that then make sure that A and B are the same data type. Because what you return with max is you have two values, you pick one, right? So what I return has to be the same data type as that value. So I would make sure my two parameters have the same data type, and then make sure this is a data type for the return value, and you're all good. So you can use double, char, whatever. Okay, but you can use definitely smaller int data types as well. So that's what I ask you to do for coding bat until we can talk about method that have multiple return statements. And that's what we're going to do right now at the end of the session here. So here's the same max, but this time I don't want to use an extra variable and return it at the end. So I just say if A is smaller than B, return B. That's the biggest, else return A. That works. That's the same logic, right? But I use two return statements. So now there are two execution paths through that code. Each of the execution paths ends with an appropriate return statement. Slight variant of this, public static int max, A and B. If A lesser than B, return B. Do I need an else? No, because if I put just return A, what I wrote pretty much is when you reach the end of this method, return A. Now, before you reach the end of the method, let me check if we should return B instead. If A lesser than B, I return B, which means when I execute the keyword return, I get out of the method. So I'm not going to ever look at this code. So that's a thing that you can use actually, and I invite you to maybe even revisit some of the logic one exercise in coding bat and see if you can rewrite them, because you can simplify them tremendously sometimes by using the fact that when you execute return in the middle of your code in the method, you don't have to care about anything that's after. So if else can become just a if return, if this return, if that return, and then return at the end. It's a perfectly valid organization. What doesn't work? This kind of stuff. What the hell? If A lesser than B, return B. If A greater than B, return A. Why isn't that correct? Yeah. So there are two things, okay? One thing is, in that example, what if A is equal to B? Okay? So this is false, I don't return B. Okay, so I continue. This is false, I don't return A. Okay, I continue. There's nothing. Missing return statement. You're supposed to return an int. It's not good enough to reach the end of the method. You need to tell me which one I return, A or B. So yes, there is a logic here that tells me this code is not good. But even if I did if A greater equal to B here, then I would fix my code, right? That error, logical error would be gone, but the compiler would still complain. Why? Because the compiler doesn't understand your code. Your compiler is like a proofreader that reads your novel only to check the grammar. So the compiler will never assume that this condition, when it's true, I'm going to do a return, and when it's false, then this condition will always be true. It's not going to be able to evaluate the condition and determine which one is always true, which one is always false, if they are complementary from one another. So you may have code that is actually very good and correct, like if A lesser than B, and then if A greater equal to B, and it's not going to be allowed by the compiler just because the compiler cannot guarantee that it's okay. All right, we're done. So again, one or two more sessions on module 8, and we are close to the end. Rejoice. Thank you.